All right, let's talk about how we can leave trails, like we can see here. All right, so what are trails good for? Well, in this case, we could be using it for leaving behind a paint trail. You could use a variation of this for leaving footprints behind if you wanted to. There's other ways to do footprints as well. This is also a similar type of technique that you could use for, again, a variation for having a character walk through the snow and be leaving this snow trail behind. Many different reasons or uses for something like this. Of course, we're going with more of a splattered look, because the specific request for this was more of a paint trail. All right, so how do we do this? Well, to start off, for my scene here, all I have is my world. I've got my sun and environment. I've got my floor, and I have my player. Now I'm going to go onto the mesh of my floor, and inside of the surface material override, we're actually going to make this a shader material. And for the shader, I went ahead, I just named it Groundy. Doesn't really matter what you name it. And in order to make this work, we have to create a very minimal shader here. And I'm just going to pull that up. And here you have it. So at the top, we're going to start with uniform for our variables, if you remember. Sampler 2D, this will be our ground texture, and the hint is a source color. Again, uniform, sampler 2D, and this is going to be our paint texture. So this is what our splatters are going to be created and shown on. And that, of course, is also a source color. Again, uniform, this time we're going to use a float, and this is going to be the paint strength. So if you want to change how strong that paint is, for example, I'm going to come in here and I'll change that strength down to, I'll change it to 0.1. And you saw what it was like at full strength. So let's take a look here. What does it look like now at 0.1? Well, it just kind of looks like we're leaving some kind of a wet trail going on in this case. Right, because it's not really strong enough to go so much above that. Let's go to 0.5. You can see the difference there. You go all the way up to 1. There it is. All right, so we can change that strength. If you want, you can think of it kind of like opacity, but not really. Let me just pull that shader back up. And that's going to have a hint range of 0.0 to 1.0. And that's by default is going to be 1.0. So if you want to change that either through your code later on or just tweak it with how you want it to look in general, you can do it there. And all three of these is going to show up inside of your shader material in the inspector under shader parameters here. This is where we have our, let me just close that up, ground texture, paint texture, and paint strength. Now for the ground texture, for this, I'm just using a normal color, but if you want, you could drag and drop a texture in there just fine. All right, so we're going to be using a fragment shader for this. So this just means we're applying it to, you can think of it as like all the pixels. This is a vector 4 because this is RGBA, right? Ground color is a texture of ground texture and our UV. And same thing with our paint color. Right, that's going to be our paint texture UV. And then all we have to do is blend it here. So our albedo, or the color, the main texture, if you're used to spatial material, they still call it albedo there as well. We're going to be mixing our ground color RGB and our paint color RGB. So we're mixing those two textures together. And then we're going to multiply the alpha, so paint color.a, times our strength. All right, so like I said, you can think of that like opacity. And that's it. That's all we have to do here. This is a very simple shader. Most of the work is going to be inside of our GDScript file. All right, so for my player, I'm going to open this up and we can take a look. Okay, so we have all the variables that we're going to use here. So we have an export for our brush size, so we can change that. 3 is what you saw in there, but you can make it a wider or a larger radius, and the splats are going to end up being further apart. We're going to have the paint color exported. By default, I've got it set as red, but you can see in the inspector here, I've gone ahead and I've made it green. The ground node is a mesh instance 3D. This way we can select what the ground is. And if you were to travel to another area or another chunk or whatever, you could always update this ground node at any time. Then we're going to have a variable for the ground material, which is a shaded material. Our paint texture, which is going to be an image texture. Our paint image, which is an image. And our last paint position as a vector 3. Now, before we can get started with that, we're going to go inside of our ready function, and we need to set this up. So our ground material is simply going to be our ground node get surface material, surface override material is 0. So we're going to get that shader material that we just created. And if we can't get that surface override material, then we're going to try to get the non-override material, right? Just a regular one that would be on the mesh itself. Now, if we don't have anything between both of those, then you kind of have a problem. But for the paint image, let's go ahead and set that up now that we have our ground material. So our paint image is going to be image.create, and this is going to be a 512 by 512 image. If you want to make this larger, you could. Nothing really stopping you. Our argument here is going to be false, and if we take a look at that, we can see that it's going to be use MIP maps. There's no need for us there. And we pass in the format of RGBA8. And we're going to go ahead and fill this entire image, so this whole 512 by 512 image, with a transparent color. So we're basically sitting here with a blank PNG. Paint texture, we're going to create a new image texture for it. And then the paint texture, set image, and pass in our paint image. So I'll say it right after this one. Our ground material, set shader parameter. So these are those parameters that we created right down here, right? Ground texture, and paint strength. And we're going to set the paint texture to our paint texture variable. So what this is doing is once we start the game, we're going to have a little splat when we land there, but once we start, that moment while we're still falling, the entire paint texture, the splatter that we're blending in, is completely empty. So it's just an empty transparent image at this point. Next up, we're going to go down to our movement. So this is going to be in our physics process. And here we go. So I only want to be splatting when I'm moving around, and I only want it to happen when I'm on the ground, right? So if I jump in the air, I don't want to be causing any splats that magically appear below me. So we can go ahead and check if global position distance to last paint position is greater than 0.2. So we're basically saying if we've moved at least this far away from the last splat that we made, and we're on the floor, then we're going to call out the function we're going to create here, paint on ground, and last paint position equals our global position. So we're updating our last position to be our current position, and we're painting on the floor here. All right, so what is this paint on ground? Well, let's go ahead and jump into that function for this. So paint on ground, that's exactly what it sounds like. It's going to do the painting on the ground. We're going to create a few variables here for local position, ground AAB, UVX, and the UVZ. Our local position is going to be our ground node to local global position. All right, so we're getting our position relative, or a local position for us to the ground, though, so we know where on the ground we're stepping effectively. Ground AAB, we're getting ground node dot get AAB. And if you take a look, we don't actually have a description for that. Never mind. That's the underscore one. We're actually using this one. You can see returns the AAB, also known as the bounding box for the visual instance. So we're getting that visual area. UVX is exactly what it sounds like. We're just getting the X and Z coordinates for the UV. That's going to be local position.x minus ground AAB dot position.x. And then we're going to divide that whole thing by ground AAB dot size.x. And we're going to do the exact same thing, but with Z instead of X. And that's going to effectively get us our coordinates on the texture. Now we're going to clamp our UV and X and Z coordinates. We're going to clamp them between the value that we have and clamp them between 0 and 1. Because 0 is going to be one corner, 1 is going to be the other corner, so that gives us our two sides, right? Two sides on the top, bottom. All right, now we create our texture for the X and for the Y. It's going to come back as an integer for us, so it's going to be the UVX times the paint image dot get width, and UVZ times the paint image dot get height. So again, we're just working on getting these positions, position on the object, position for the UV and the texture. And as you can see, we're going to use paints. I'm using paint splat instead of paintbrush. I used to have one called paintbrush, which is just kind of a circle area. It's not really a splat. And something like that is more like the direction that you would go if you want to do like leaving a snow trail behind a ball or something. Or not snow trail, but you go with like a dent in it. But of course, you have to create variations into the shader to account for height. Anyway, this is going to be another function of ours that we create called paint splat. It's going to take our text X, our text Y, our brush size, and the paint color. And then we're going to go paint texture dot update and pass in that paint image. All right, now we're going to need that paintbrush. Sorry, not the paintbrush. We're going to be using the other one, but I wanted to show you the paintbrush here. So as you can see, it's just more of a splatter, not much of a splatter. It's more of a one-line thing. So if I were to come here, go to my character, stop this, and for this, I want to increase this maybe to a size 10 brush size. You can see we can drop in, and we can kind of leave that circular impression. Now, if that's something that you want, cool, then you want the paintbrush. So I'm going to show you the paintbrush in case you just want something simple like this. But if you want the splatters, then that's the other option that we're going to be using that I mentioned here. That's going to be our paint splat. Right, and again, that's just the same arguments. But I'm going to use the splat for this. But if you want the paintbrush, here it is again, the same argument: center X, center Y, our radius, and the color. And just extend that again, and we're going to run inside of a for loop. So for X in range, center X minus radius, and center X plus radius plus 1. And then for Y, so we're just running through a grid, right? An X and a Y. For Y in range, center Y minus radius, and center Y plus radius plus 1. And then we go into an if check. So if X is greater than or equal to 0, so we're making sure that it's not negative somehow. And X is less than our paint image get width, so if we're not somehow going past the size of our image. And again, same thing with our Y, so as long as we're larger than 0, larger than or equal to 0, and Y is smaller than the height of our image, then we can go ahead, we'll get the distance. So distance is just a vector 2 of our X minus the center X, and Y minus the center Y, dot length. I'm sure you've used that before if you've gotten the length between the two positions. So we're going to check if distance is less than or equal to our radius. Right, so we're keeping ourselves contained within a sphere, right, inside that paintbrush size. Alpha is 1.0 minus our distance divided by radius. The current, we can get that with paintImage.getPixel.xy. So that's the current pixel that we're on. And then for our blend, we're going to do current.lerp, pass in the color and the alpha times color.a. And paintImage.setPixel.xy blended. Right, so we're just updating all the pixels within our radius. Right, so that's what you want if you want that circle that you just saw with paintbrush. Now, if you want the splats, it's going to be, as you can see, a little more complicated. So let me just come back up. Paint splat, again, the same argument, center X, center Y, radius, and color. Var, our main radius is going to be equal to our radius. Right, so we're just setting that. You don't really have to, but it's what I'm going to use. For the angle in range of 0, 360, 10. So it's going to give us in 10 degree increments here. So we're going to have angles 0, 10, 20, 30, 40, all the way up to 360. Our var, our rad, is going to be just the radians of our angles. So degrees to radians. And pass an angle so that we can get the radians of this. And you can, as you can see from my note here, this is going to be our random variations inside of that radius. I was going to say radius for an irregular edge, so it's not a smooth edge, right? It appears a little more random. So our splat radius is going to be our main radius times a random number between 0.7 and 1.2. Right, and as you see here, we're going to draw from the center out along the angle. So for distance in range of 0 and our splat radius, we're going to get our x and y. So x is going to be our center x plus the cosine of our the cosine of our radians times our distance, and the y is going to be our center y plus the sine of our radians times distance. So that's going to get us our x and y here. I know this seems a lot complicated, especially compared to the paintbrush. So hopefully you're following along here and hopefully understanding what's going on. All we're really doing with this so far has just been math to figure everything out. So let's continue. If x is, again, just like we did before, right? So if x is greater than or equal to 0, but it's smaller than the width. Same with our y, if it's greater than or equal to 0 and smaller than the height of our image. Right, paintImage.getHeight. Then, as you see here, we're going to fade the alpha towards the edges, so it's not such a hard edge. Alpha fade is 1 minus distance over splat radius. So that's just going to get our alpha. The splat color is going to be color.r, color.g, color.b. And then the alpha is all that we're modifying, so color A times our alpha fade. And remember, that's the color that we are going to be picking up in our variable. Current will be our, just like before with our brush, paintImage.getPixel x and y. And then blended is current.lerp, splat color, splatcolor.a. Paint image, set the pixel of x, y, and blended. And now we can get onto those random droplets that are around our main splat. So if you were to stop here, this is what you're looking at, right? Just this little quick splat. You'll see it again when we land here. We're just going to get a splat. So if you were to walk around and have it constantly going, this is what we're looking at. All right, so if this is the look that you like so far, great, that's all you can use. And if you were doing maybe a like a paintball game, then maybe this splat is good enough for you. So if this is enough for you, then you can go ahead and stop there. Your paint splat is done. But we're going to go ahead and we're going to continue for the next section. So let me just uncomment this out. All right, so we're going to add the random droplets around our main splat. Droplet count is going to be a random integer between 3 and 8. Then we can go into a for loop for I in droplet count. Right, so we're going to have a random amount between 3 and 8, and for every one of those droplets, basically, we're going to set droplet angle as a random float, and that's just between 0 and 1 by default, times pi times 2. The droplet distance will be a random range of radius times 1.2 and radius times 2.0. Our droplet x, we're going to get that center x, and this is the same thing that we used up above for our main splat, if you remember up here when we went into our for distance loop, right? And we had center x times the int of cosine radians times distance. That's the same thing that we're doing down here. So the droplet of x is going to be the center x plus the int of cosine droplet angle times our droplet distance. And droplet y will be our center y plus the int of sine droplet angle times droplet distance. The size is going to be a random integer size between 1 and 3. And you can tweak these numbers if you want to get the results that you want. And let's see what happens if we stop here. What kind of a result do we have? Well, we can see the droplets here aren't really getting used. Yeah, so I guess we're actually not going to be able to stop that there. So we're going to have to continue to actually... We're getting our droplets, but we haven't actually painted them. So my mistake there. So we're going to say for dx, and again, call this whatever you want. This is just our droplet x and droplet y, right? We're just doing our x and y loop. So for dx in range negative droplet size to droplet size plus 1. And for our droplet y in our range of negative size to size plus 1, we're going to go ahead and create two variables, px and py, and that's going to droplet x plus our dx and droplet y plus dy. And now we can go into if px, and again, this is familiar. This is what we've done 2 or 3 times now. If as long as it's px is greater than or equal to 0, and px is smaller than the width, and py is greater than or equal to 0, and py is smaller than the height. So notice we're doing a similar thing all throughout this. Right, so we can do if dx times dx plus dy plus dy, dy times dy is less than or equal to our droplet size times droplet size. Then we can go ahead and we're actually going to set our pixel now. And again, this is stuff we've already done. Current of our current is going to be our paint image, get pixel, our px and py. Our blended variable is going to be current.lerp, color A times 0.7. And our paint image, we're going to set that pixel for px, py, and to set it to the blended. Right, and with that set, we now have this as our result. And you can see how spread out these are and how big they get when we have large brush sizes. Now this is a size of 10, and you can see our initial splat in the middle, and then the splats from our droplets that are all out there. And you see if we splat again over here, we're going to have a different result because we got some randomness going. Right? Now you might be thinking this doesn't really look like what we saw in the beginning, and that would be fair, except this is with a size 10. I use a size 3 in the beginning, so if I set that back again, there you go. Now, going for this, personally, I prefer a 2, so just dropping it 1 more. And to me, that's a better result if we're just going for a splatter here. And if we just jump and just do a nice splat, right, that's what we got. Not too big, it's just a nice little clump underneath of us. So again, you could cut that whole chunk off if you just want that initial splat. Or if you want to have, well, more of these kind of splats, then you're going to have to do that little bit extra to put those extra droplets in. Either way, that's completely up to you and dependent on how you want yours to look. Or again, you could ignore that and go with the simpler paintbrush and just have that circle kind of trail following you. So the choice is yours, whether you want the brush or the splats. But that's how you go about doing that and creating these splats. Again, you could use this for a variation of this is used for like snow trails when a character is walking through it, or you could use it for simple trails like this. Or like I suggested earlier, if you've got a paintball game, I don't know what I was going for there. You could use that for your initial splat when the ball hits the wall or something. All right. So that's it. Take care. Have yourselves a good one, and I'll see you guys next week.